Welcome to Study Loop.
Yes, the sample sizes are sufficiently large for the sampling distribution of the differences between the sample proportions to be approximately normally distributed. To check if the sample sizes are large enough, we need to ensure that both NP and n times 1 minus p are greater than or equal to 5 for both samples, where n is the sample size and p is the sample proportion. So for the first sample, where the sample size is 200 and x is 30, p hat is going to be 30 over 200, which is 0.15. And so n times p1 would be equal to 200 times 0.15, which is equal to 30. And n times 1 minus p1 would be 200 times 0.85, which is 170. For the second sample, where n is 50, the number is 24, and so p hat sample proportion is going to be 24 out of 50, and that's 0.48. So 50 times 0.48 is 24, and n times 1 minus p2 is going to be 50 times 0.52, which is 26. So in both samples, np and n times 1 minus p are greater than or equal to 5, which means the sample sizes are large enough. To calculate the 99% confidence interval for the difference between the two population proportions, we can use the formula the confidence interval is equal to the difference between the sample proportions plus or minus a critical z times the square root of the first sample proportion times 1 minus the first sample proportion over the first sample size, plus the second sample proportion times 1 minus the second sample proportion over the second sample size. So that's going to be, when plugging everything in, 0.15 minus 0.48 plus or minus a critical z for 99% confidence is 2.576. The sample proportion for the first sample was 0.15, and that sample size was 200. And the sample proportion for the second was 0.48, and there were 50 of them. We find the lower boundary by subtracting. And that comes out to 3 decimal places. We'll go negative 0.523, and the upper boundary is found by adding, and that comes out to negative 0.137. So the 99% confidence interval for the difference between the two population proportions is approximately negative 0.523 to negative 0.137.